Four equal charges, 2 into 10 to the power minus 6 coulomb each, are fixed at the four corners of a square of side 5 centimeter. Find the Coulomb force experienced by one of the charges due to the rest of the three charges. So for this particular question, we begin by drawing a square arrangement which the question is talking about. So we consider a square like this. Now the charges are placed on the vertices of the square. Like this. Now the charges are of equal magnitude. Q equals 2 into 10 to the power minus 6 coulomb. They are fixed at the four corners of the square of side 5 centimeter. So the separation or the side we can say is 5 centimeter, which we mention it as A. So A equals 5 centimeter. Find the Coulomb force experienced by one of the charges due to the rest of the three charges. So I am calculating force on this charge. So the first force which we identify is the repulsion force due to this charge, which will act in this direction. So if I name the charges, I call it as 1, 2, 3 and 4. So we are calling this as F14, the force which the 4 experiences due to 1. Now 3 is going to repel 4 in this direction. So we are calling this as F34. And 2 is repelling 4 in this direction, which we call it as F24. So these are the three forces we identify first of all. Now the magnitude of F14 and F34 is going to be same because the separation and the magnitude of charge is same for both 3 and 1. So we write this force as K Q1 Q2 by the square side A square. Now if we talk about F24 magnitude, so the separation between the two charges is this time becoming root 2a. So if the side length is a and a, so this the diagonal length will become root 2a. So we write it as kq square upon root 2a whole square, which we write as kq square by 2a square. Now it is important that while solving this out, we make the component and then we write the value of the net resultant value of the force. So for calculating the net resultant, we are first of all calculating the resultant of 3 and 3, 4 and F14. So FR1, I am calling this as FR1, which is equal to F14 magnitude square plus F34 magnitude square. It is because the two forces are at an angle of 90 degree, so their resultant will be along their angle bisector line, that is along F24. So the net resultant magnitude which we talk about is going to be the magnitude of FR1 and the magnitude of F24. So if I calculate the magnitude of Fr1, since both the forces is same, so we write it as F square plus F square square root, which we write as root 2F. So it is equal to root 2F plus F24, where F is written as this force, kq square by a square. So if we put the value, that is we get it as root 2 times of kq square by a square plus kq square by 2a square. Kq square by 2 square for F24. Kq square by 2a square. So on solving we find that the net resultant is coming out to be 27.56 Newton. Now the only requirement is to substitute the value of K and Q and do the mathematical aspect. Let us move to the next question.